All right, we're going to go ahead and get started on homework number 9. And the name for this homework is Solve by Graphing. Okay, so we're going to start off by looking at two variable inequalities. And if you remember, our inequalities that we work with are less than, greater than, less than or equal to, and greater than or equal to. And these are our 4 basic inequalities we're going to deal with. So I'll go ahead and I'll just say these are our 4 basic inequalities. Okay, so whenever you hear the word inequality, right, remember in equal, so it's not an equal sign, right? So in equal, so it deals with those symbols. All right, so we're going to go ahead and take a look at this because the steps, I guess the directions say graph each inequality, and it gives you a list of 4 different inequalities, numbers 1 through 4. So we're going to go through them. So we'll go ahead and start off with number 1. Okay, and number 1, the inequality they give you is y is greater than 2x plus 1. And we've been told to graph the inequality. Okay, so we got to graph this. So when I'm going to graph inequalities, I'm going to go ahead and start making my steps. The first thing I want to do is I want to create a table of values. And I want to be able to find 2 points to graph. Okay? And the way you would find that is by creating my table of values. I'm not going to make it too big, so I'm only going to find 2 points, right? And you would just find 2 points because we're going to find a line, and then we'll graph it from there. But you only need 2 points for a line. So I'm going to go ahead and you can select any 2 x values you want, but the easier ones I'm going to say are 0 and 1. So in this case, if I were to substitute in 0 for this, right, if I substitute in 2 times 0 plus 1, that just gives me 0 plus 1, which is 1. And then if I substitute in 1 for x, 2 times 1 plus 1, 2 times 1 is 2 plus 1 equals 3. Okay, so now I got my 2 points. So I'm going to graph this. So I'm going to create my coordinate plane. This is my y-axis. And this is going to be my x-axis. Okay? My 2 points are going to be 0, 1, and then also 1 up 3. 1, 2, 3. So those are my 2 points. Okay, I got 0, 1, and then 1, 3. Now, if we were just drawing a line, right, if I were just graphing an equation, I would go ahead here and draw my line and go about business that way and be done. But we're not doing that, okay? We're graphing an inequality here. And something to know about inequalities. The same way when we were graphing inequalities on a number line, right? When we were doing it that way, when we're graphing inequalities on a coordinate plane like this, we're going to have to realize a few things. One, whenever you're dealing with, I'm going to go ahead and draw this up above here. Whenever you're dealing with less than or greater than, what you're going to do is you're going to graph with a dashed line. Okay? And it kind of looks like that, right? And then over here, less than or equal to or greater than or equal to, we're going to graph with a solid line. Okay, so whenever we see less than or greater than, we're going to graph with a dashed line. So it looks like this. And right, and then you go ahead and draw your line like that. So knowing that, we have a greater than symbol in number 1. So knowing I have my greater than symbol, whenever I have a less than or greater than, I need a dashed line. Okay, so I'm going to go ahead and draw my dashed line. Okay, and I've done that. So number 1, my first step was to create a table of values. And if I were to go ahead and write over here, even though it's sideways, I'm just going to keep track of it. My second step would have been to graph the 2 points and then connect with a dashed or solid line. And my fourth step, what I'm going to do is, I'm going to be able to shade above or below. Like I said, I know I'm writing sideways there and you might have to look that way. And I'll go ahead and rewrite these for the next problem too, so you don't have to worry about that. But in this case, it's saying y is greater than 2x plus 1. And I remember in Algebra 1 we went through this. But all the values that are greater than, all the values that are above the line. Okay, so if we're looking at all the values that are greater than above this dashed line, it's going to be all the values on this side of the line. So I would shade in everything on this side of the line. I'd shade it in, right, everything on this side of the line. Because these are all the values that are greater than, okay, above the line. That's why we use the greater than symbol. So just to recap, first what we did was we created our table of values. We found our 2 points. We plotted our 2 points. We then connected that with a solid or dashed line. A solid line would have looked something like this, right? Look in the bottom right corner there. And that would have been for if I had less than or equal to or greater than or equal to. But since I have one of these, I'm going to graph it with a dashed line. And then once you do that, you're going to go ahead and shade everything above because it's all the values greater than. Y is greater than all the y values above. So all these y values up there. Okay, so that's how I would answer number 1. The next few problems are similar, so we're going to square this away here in the next few problems. Okay, so number 2. Number 2 still says to graph the inequality, and the inequality is y is less than 3x minus 2. All right, so I'll go ahead and write out my steps going down this way. All right, so I need my table of values. Okay, and really I need 2 points. Then I'm going to graph my 2 points. Then I'm going to connect with solid or dashed line. And last thing I'm going to do is shade above or below. All right, so let's go ahead and take a look at this. So I have y is less than 3x minus 2. I'm going to go ahead and create my table of values. And I'm just going to add like this. And I'll go ahead and say 0. and 1. Those are my two easiest ones that I like to use. So if I do that, 3 times 0 is 0, minus 2 is negative 2. 3 times 1 is 3. 3 minus 2 is 1. All right, so those are my 2 points. And then what I'm going to do is I'm going to draw my coordinate plane. And I'm going to draw it this way. All right, and it says graph my 2 points. So I have 0, minus 2, and 1, 1. Okay, so I have 0, negative 2. I have 1, 1. I have my y-axis and my x-axis. Okay, so I've done step 1, I've done step 2. Now it says connect with a solid or dashed line. Now remember, these two use a dashed line, and these two use a solid line. So in this case, I'm going to use a dashed line again because I'm dealing with this one right here, right? So if I just draw this, okay. So I'm going to go ahead here and connect it with a few dashes, and then draw an arrow on the end of it, means it's going on forever. I've done that. And shade above or below. So all the values that are less than, all the y values that are less than down there. So I'm going to go ahead and shade everything below the line. These are all the values below the line. Right? And this isn't very pretty, right? I'm just shading all this in and everything on this side of the line because all the values below the line. And I've done that. Okay, so now moving on, we're going to move to number 3. Number 3 is y is less than or equal to x plus 3. Okay, so create my table of values. Doesn't have to be really big because I'm going to use 2. You only need 2 points in this case because you only need 2 points for a line. So I'm going to say 0 and 1. 0 plus 3 is 3. 1 plus 3 is 4. So I go ahead and I'm going to draw my coordinate plane. All right, and go ahead and add my arrows on the end. That was kind of ugly, so I'm going to do that again. All right, so 0, 3, 1, 2, 3, and then 1, 4, 1, and up 4, so right there. And remember, since I have this symbol right here, a less than or equal to, it's going to be a solid line that goes through it. So, oh wow, that's ugly. It doesn't even go through it. Let's try that. All right, so there we go. All right, there's my solid line and all the values that are less than or equal to. Less than or equal to, so all the values down here that are less than. So you can shade all that in. All right, shading all that. Everything down below here. All the values that are less than. Okay, and that's number 3. Now we're getting the hang of this, number 4, and we have y is greater than or equal to 2x minus 2. All right, so step 1, create my table of values. I'm getting used to this by now. And I say 0, and I'll say 0, 1. Okay, 0 times 2 is 0, minus 2 is negative 2. 2 times 1 is 2, minus 2 is 0. Okay, so I've got my 2 points. I'm going to go ahead and graph them. Okay, so 0, negative 2, and 1, 0. And once again, this is going to be a solid line that goes through these 2 points. And the reason I know that is because of this symbol right here. It's a greater than or equal to symbol. And all the values that are greater than. So I'm going to go ahead and shade in all this up here. Right, so all these values above the line. All right, and that will be number 4. So now we got the hang of it. We should know how to graph these inequalities. Okay, number 5, I'm going to move on to the next page here. Number 5 says graph each absolute value inequality. And the absolute inequality they give us is y is greater than or equal to the absolute value of 2x minus 1. Okay, so here's the deal with this problem. Okay, we still are going to follow the same exact method of graphing with our dashed and solid lines using the inequality. So, these two still have a dashed line, and these two still have a solid line. But remember, when we're dealing with absolute value, we know that our shape is going to be a V shape, right? So we're going to have to graph this, and when we graph it, it should give us a V shape. If it does not give us a V shape, and when I say V shape, it should look like this. Okay, and remember, this would be the other version of it if it was a dashed line. But we know we're going to get a V shape. If we don't get a V shape, that's because you've messed up somewhere, plain and simple. Okay, so we're going to go ahead and do that. Let's see what we get. I might have to add some values down here below, but we'll see. So I like using, with absolute value, I know usually I always say, oh, my 3 favorite points to pick are 0, 1, and 2. But with absolute value, it's good to pick some negative values as well, just so that way we're able to graph on the left side of the y-axis. So I'm going to say -1, 0, and 1. We'll start there. Okay. And in this case, we'll start off with -1, and I'll go ahead and substitute that value in. So I'll say 2, absolute value of 2 times -1 minus 1. Whoops. All right. So I start off with, as far as I go inside of multiplication, so 2 times -1 is -2. -2 minus 1 is equal to the absolute value of -3. The absolute value of -3 is 3. Okay. And then I'll do 0, right? 2 times 0 is 0. 0 minus 1 is -1. The absolute value of -1 is a positive 1. All right. Let's try 1. 2 times 1 is 2. 2 minus 1 is 1. The absolute value of 1 is 1. Do that right? Yes. 0, 1, 1, 1. 0, -1. Let me just make sure I'm doing this right here. 0, 1. 2 times 1 is 2. 2 minus 1 is 1. All right, so yeah, I guess that's right. This is a graph what we have so far. Okay. Let's see what we get. So far I have -1, up 3, 1, 2, and 3. I have 0, 1. And I also have 1, 1. Which is interesting, right? And then let's see what happens if I put 2, right? Positive 2. So 2 times 2 is 4. 4 minus 1 is 3. The absolute value of 3 is 3. Okay. So I have 2 up 3. So I haven't found my vertex, but I think my vertex is going to be right. I think it's going to be right here at 0.5. That's the way it looks like it. And maybe if I substitute in 0.5, right, so I'll add another value onto my XY table, right? If I add on 0.5, right? 2 times 0.5 is 1. 1 minus 1 is 0. Absolute value is 0, so that's exactly what it gives me. Right, so this would be my graph. Okay, that's the tricky part there is this 0.5. If you haven't found the vertex by your points, you're going to have to keep on entering different values. And what I saw was, before I even put this point here, I'll go ahead and draw it over here. I saw these values. I started to slow up because I was like, wait, what's going on? Why don't I have the vertex yet? Well, the vertex was 0.5, and that's how I ended up getting it there. And then I connected the two together and drew it. Okay, so it might require you to add some extra x values in order to find the right value. And now that I'm here, right, I'm still not done because it asks me to graph all the values that are greater than or equal to. So I still have to shade in all these values up here, all these values that are greater than. So anything that's above this line. So that's what that would look like. And remember, those lines go on forever and ever and ever and ever. That's why they have arrows on the end of them. All right, so that would be number 5. Okay, number 6. Number 6 has y is less than or equal to absolute value of 2x plus 2. Okay, so once again, we're going to go ahead here and graph this. So I'm going to go ahead and just going to create a table of values. I'll use some, I'll use -1, I'll use 0, I'll use a few. Ready? I'll go -2, -1, 0, 1, and 2. I'll just start with these 5. Okay. And I just like choosing a few on these two right here, a few on the left side of the y-axis, as well as a few on the right side. Okay. So let's substitute these values in. 2 times -2 gives me a -4. Okay, absolute value of -4 is a +4. 4 plus 2 is 6. Okay. -1. 2 times -1 is -2. The absolute value of -2 is a +2. 2 plus 2 is 4. 0 times anything is 0. The absolute value of 0 is 0. 0 plus 2 is 2. All right. Let's see. 1, and then it goes back the other way. We're going to end up getting a 4 here. And we're going to end up getting 2 times 2 is 4, sure enough, and we get a 6. All right. And then I'm going to draw my coordinate plane. All right. And I'm going to plot my points. -2 up 6. 1, 2, 3, 4, 5, 6. And then -1 up 4. 1, 2, 3, 4. 0, 2. 1 up 4. 2 up 6. All right, and I'll graph that like that. Okay, and now we have less than or equal to, so all the values that are less than, so everything below our lines, right? Everything that's below. So all of this, right? I'm just shading all of this in, showing that all of these values are what I'm looking for. Okay, so you shade in all of those values. All right, number 7. Okay, number 7 is y is less than the absolute value of x. All right, so we'll go ahead and make our table here. This one's going to be a easier one. So we'll say -2, -1, 0, 1, and 2. The absolute value of -2 is 2, of 1 is 1, 0, 0, 1, 1, 2, 2. All right, and as you know, this is our parent function that we talked about last week. So we're really just graphing our parent function, but we want all the values in the inequality, all the values that are less than. So we're going to graph this -2 up 2. Right, and then we got our -1, 1, 0, 0, 1, 1, and 2, 2. So I graph that line, and I graph that line, and all the values that are less than, which is everything that is below the line. So I'm shading in, signifying that these are all the values less than. All right, all the values that are less than. And that's number 7. Okay. Number 8, moving on. All right. Number 8 talks about solving systems by graphing. And what we're going to ultimately do here is whenever you see something saying solve the system, now we're going to be talking about in the upcoming lessons how to solve systems of equations, systems of inequalities, and we'll learn how to do it by graphing, by substitution, by elimination. There's many different methods to solve it, but in this case, we're going to solve the system by graphing. Okay, and a system is just a series of equations or inequalities. In this case, with number 8, we have 2 different equations we're dealing with. And, we have y equals x minus 2. That's written in slope-intercept form. And then also written in slope-intercept form, y equals -2x plus 7. And sometimes you might see it written like this. Like, hey, this is your system. Just letting you know, sometimes you'll see it like that. But this case doesn't have it like that. All right. So it says solve each system by graphing or using a table. Make sure to include the solution as an ordered pair and to check your answers. Okay, so it says by graphing or using a table. So what I'm going to do is I'm going to solve 8, 9, 10. I'm going to solve 8, 9, and 10 not using a calculator. And then I'm going to go through and show you how to solve those with a calculator because it will make you appreciate using a calculator in these situations. It makes it a lot easier. Okay, so solve the system by graphing. So, if you're going to graph, right, y equals x minus 2. Now we're back to equations. We only need 2 points, right? So if we create our table, and I just choose 0, and I'll choose 2 as well. Okay, so 0 minus 2 is -2. 2 minus 2 is 0. And if I'm going to be graphing, I'll make this nice and big. And that line will straighten out. And I'll say 0, negative 2, and then 2, 0. Okay? Since this is just an equation, right? We're going to go ahead and connect it with a solid line. It's not an inequality, right? So now I'm going to use a solid line. And then I have y equals negative 2x plus 7. Okay, so thinking what values should I use? You can just use 0 and 1, 0 and 2. Let's choose 0 and 1. Okay, so negative 2 times 0 is 0, plus 7 is 7. All right, and then I have 1 times negative 2, which is negative 2. Negative 2 plus 7 is a positive 5. So 0, 7, 1, 2, 3, 4, 5, 6, 7. And 1, 5. 1, 2, 3, 4, 5. Okay, so if I were to draw this line right here, remember my graph isn't perfect, right? It looks like this is about right, okay? Now, once again, my graph is not perfect, but where these two lines intersect, and maybe I'll make my graph a little nicer, right? I think one thing I did was now I'm going way too far back. 1, 5, okay? One thing I did was this line right here I'll move that right there, okay? So I'm going to just be really careful about where I plot these points. 0, 7 was 1, 2, 3, 4, 5, 6, 7. Try to make the increments as close as possible, right? And then 1, 5. 1, 2, 3, 4, 5. Okay? So this line that goes through, I'll draw it again, right? And it went all the way through over here. Okay? So I have these two lines. The reason why I redrew that is because I'm not perfect when I draw lines, and you'll see why it's easier to use your graphing calculator. But in this case, you have these two lines. The first one that I drew was y equals x minus 2. And the second one I drew was y equals negative 2x plus 7. Okay? And I drew them by just creating my table of values. Now the solution to this is where these 2 points, or where these 2 lines meet. Okay, so that is going to be my solution. Okay, so when it says solve the system, what you really want it to find is, you want to find where the 2 lines cross. In this case, it looks like it's at 3, 1, 2, 3, and then up 1. It looks like, so I'm going to write 3, 1, question mark. It might be there. So the way I can tell is, if I substitute 3 in, if I can get 1 there, and if I can get 1 there, that's how I know that they cross. So 3 minus 2 is 1. And in this case down here, negative 2 times 3 is negative 6. Negative 6 plus 7 is 1. So sure enough, these 2 match. Which means, since those 2 match, that's going to be my solution. So my answer in all of this is 3, 1. That is what solves the system. Now, originally, if you looked right here, I was kind of guessing, and I wanted to see if that was right. And since I don't always draw the neatest, and my graphs aren't always the neatest, sometimes my guess could be off. And if it wasn't 3, 1, I'd still guess maybe it was like 4, 1, right? Or 3, 2. So you have an idea of what it would be. But this isn't perfect, like I just said. Like, sometimes you mess up, so that's why a calculator is better. That's why I'm going to be doing some of these problems with a calculator here in a second. All right, so that was number 8. Number 9, it says the same exact directions. Y is equal to 3x plus 1, and then I have y is equal to 2x plus 3. Okay, so let's just say I take y is equal to 3x plus 1. I create my table of values here. Remember, all I need are 2 points. So I'm just going to choose 0 and 1. 3 times 0 is 0. 0 plus 1 is 1. 3 times 1 is 3. 3 plus 1 is 4. Okay, so I'm going to go ahead here and make my graph. And it goes that way as well. And I have 0, 1. I have 1, 4, 2, 3, 4. And I'm going to draw a line that connects my 2 points. That doesn't look the best. I'm going to try that again. I'm going to start here. There you go. That will do. Right. All right, that's my first line. And then I'll say y is equal to 2x plus 3. I'm going to try those same values. I'm just going to try 0 and 1. 2 times 0 is 0. 0 plus 3 is 3. 2 times 1 is 2. 2 plus 3 is 5. Okay, so 0, 1, 2, 3. Sorry, 1, 2, 3. And then I have a 1, 5. 1, 2, 3, 4, 5. Okay, so if I look at that right about there. So let me go ahead and draw my line. And I'm going to go ahead and leave it there. And it looks like it kind of goes off the graph here. And my solution of where they intercept is going to be about here, right? So it's not going to be perfect. I'm going to have to start guessing. That looks about like, I don't know, maybe 3, 1, 2, 3, 4, 5, 6, 7, 3, 7 maybe, right? So I'm guessing maybe is that 3, 7? I don't know. So what I can do is I can go ahead and try it. Let's go ahead and try that value down here. And let's try this value down here and let's see what we get. All right, so 3 times 3 is 9, plus 1 is 10, okay? And then in this case, we have 2 times 3 is 6. 6 plus 3 is 9, okay? So that's not right. Maybe I can try 4. Let's see if 4 works. 3 times 4 is 12. 12 plus 1 is 13. That's not right. And then 2 times 4 is 8. 8 plus 3 is 11. So right now, I'm not sure what that value is. I've tried 0. I've tried 1. Maybe I can try 2, right? So I'll just go ahead and add this over here. So I'll try 2. 3 times 2 is 6, plus 1 is 7. All right, let's try this. I'll try 2. 2 times 2 is 4, plus 3 is 7. So somehow, like I said, like that's why I'm not the best drawer. Somehow that's not 3, 7. Somehow that has to line up, and that's 2, 7. So that was wrong. It wasn't 3, 7. by having the same values there, I've found that it's 2, 7. So 2, 7 is my answer, because 2, 7 solves both, and it solves the system of equations. Okay, so I've done 8, I've done 9. Now let's move on to number 10. All right, number 10. Number 10 gives me x is equal to negative 3 and y is equal to 5. So this one could seem a little bit tricky, but actually it's really simple. I gave you an easy one. Ready? So if I went through here and drew it like that, and I said x is equal to negative 3. That means I just say 1, 2, 3, and I draw a straight line right through that. And this line equation is x is equal to negative 3. It's a straight up and down line, right? With no slope or undefined slope. Okay. And then I'm going to have y is equal to 5. 1, 2, 3, 4, 5. All right, so that goes that way. First of all, let me just do this line a little nicer. There we go. And it's not how I like it. I want it to be nice and straight. Straight enough. All right, and then this line right here was y equals 5. Because I know that this is 1, 2, 3, 4, 5. And this was negative 1, negative 2, negative 3. If that's my x-axis and that's my y-axis, then that's right. And my answer is going to be right where those two lines meet. Okay, so right where negative 3. So this is an easy problem because I've already given you the answer. The answer here is going to be negative 3, 5, because this point right here is negative 3, 5. Because we said x is equal to negative 3 and y is equal to 5, right? But by graphing it, we see that that's the right answer. Okay? And what we'll do is, I'll go ahead and do number 11 and 12, and then I'll go back and do the calculator version of the other ones. So I'll keep moving through and then I'll do the calculator at the end. Make sure to go back at the make sure to look at the calculator section at the very end of this video, because that's going to show you a lot easier way to make this work, okay? So number 11 says, a store sells a small notebook for $8 and a large notebook. So I'll say small notebook. I always like taking notes, right? Small notebook is $8. And a large notebook is going to be $10. And it says we bought 6 notebooks total. And we spent $56. All right. How many of each size notebook did you buy? Okay, so here's how we would solve this. Well, first, the small notebook, okay? I'm going to go ahead and represent small notebooks with a variable s, okay? Every time you see s, just think of small notebook. So, if I have a notebook right here, here's the small notebook, and then I'll say for the large notebook, I'll represent that with an L, right? So the large notebook, because I'm a very visual person. So I want to write an equation, okay, eventually. I'm going to write 2 equations. That's my goal. So if I say my goal is to write 2 equations, I guess that's the first step of my goal. The second one is to graph each to solve. Okay, so that's my goal in all this. That's what I want to do. So I know that I bought 6 notebooks. So that means whatever number of small notebooks I bought and large notebooks, so I have my small notebooks and my large notebooks, if I add them together, they have to give me 6, right? Because if I bought only small and large notebooks, even if I bought 0 small and 6 large, right, I could buy 1 small and 5 large, or 2 small and 4 large. And as long as they add up to 6, I know I bought 6 notebooks, right? Also, it says I spent $56. Okay, so I know I bought $56. And I know that the small notebook, if I add that to the price of the large notebook, I know what's going to happen is I'm going to end up getting 56. All right, so let's say I wanted to graph this. All right, so you might think, well, I could play around with this, and one method that would be used perfectly to solve this would be the substitution method. We haven't learned that yet. We'll learn that next week. But in the meantime, what we want to do is we want to isolate a variable. Okay, and we want to graph it the same way when we graph something. We say like y is equal to, 2x plus 2. We've isolated that variable and we're able to graph it. So in this case, we want to isolate a variable. So I'll start with s plus l is equal to 6. Let's go ahead and let's just, let's isolate the s. Okay, so I'll say s is equal to 6 minus l, because I subtract l, move it to that side, right? So I can have s is equal to 6 minus l. And then also, if I have 8s plus 10l is equal to 56, if I want to isolate the s, I can subtract 10l from each side, right? That would give me 8s is equal to negative 10l plus 56. I divide everything by 8 in order to get s by itself. And I get s is equal to negative 10 over 8. That's the same as negative 5 over 2. Sorry, negative 5 over 4. Right? It's the same thing as that. Plus 56 divided by 8 is 7. Okay? So I've got these 2 equations here. And I go ahead and graph them and see if I can somehow find my answer. Now normally, like I said, this is going to take a graphing calculator to get perfectly right. So this is going to be a trial and error process. If I have s is equal to 6 minus l, right? That's the same as writing s is equal to negative l plus 6, right? And the reason I do that is because that kind of looks like slope-intercept form. So let's go ahead and let's try and graph that. If I say s is equal to negative l plus 6, and if I create my, just create like an l and an s here, as in my x and y, right? If I created my x and y, just like my s is my y, I can say s and l. If I add a couple points in here, let's see, maybe I try 0, and I'll do 6. I'm just looking at this number. I can get an easy number there. So 0 plus 6 gives me 6. And then negative 6 plus 6 is 0. So I have a positive 6. 1, 2, 3, 4, 5, 6. And then 6, 0, 1, 2, 3, 4, 5, and 6. Okay. And I'm going to go ahead here and draw my line. that goes through these. Okay, and that is my line for s equals negative L plus 6. All right, and then I'm gonna use s is equal to negative 5/4 L plus 7. If I still use L and S as my x and y, right? Don't be too confused by that. That's just x and y. Maybe I'll use 0, that would give me 7. And then if I use 4, right, that would give me negative 5. Negative 5 plus 7 is a positive 2. So 0, 1, 2, 3, 4, 5, 6, 7. And then 4, 2, 1, 2, 3, 4, 1, 2. Okay, so looks about good right there. Okay, so if I'm looking at these, where I know that this is going to be my solution, but I don't know what that number is. It looks kind of like, is that like 2, 4? 2, 4? Maybe? No, let's just guess, right? I don't know, maybe that's 2, 4. We can try it out. Okay, 2 plus 4. So if I go to substitute into these original equations, right? 2 and 4. Or let's try 2 and 4. 2 times 8 is 16. And 10 times 4 is 40. 16 plus 40 equals 56, right? So that is 2, 4. So 2, 4 is my solution, right? Crazy enough, it looks like 2, 4 was the right one. And the way I checked it was just substituting into the original equation of what I started with to see if that would work. So we used a graph in order to solve to see how many notebooks were actually bought based off of the information they gave us, right? Now, all this work, you might think, oh, there has to be an easier way, and there is, and it's using your graphing calculator. But all this work for one problem here, right? That's a lot. I'll show you the graphing calculator way. And on the test, you're going to be allowed to use your graphing calculator, but it's going to make you appreciate the capability of it. Okay? Actually, for number 12, I'm going to go ahead and just show you the graphing calculator way rather than doing that. So here you go. All right, so I'm going to show you in a lot easier way to solve numbers 8 through 12. So first off, number 8. Remember, we were trying to find where y equals x minus 2 and y equals negative 2x plus 7, where the graph of that intersected. So here's what I can do. I can go to my top left corner, there's a y equals button, click it. Now once I'm here, I can enter each equation. So y1 is just saying that's the first y equals equation I've got to deal with. So I'll say y equals, and if you click here, this button xt theta n, click that. That's your variable button, and that will give you an x. Okay, so x minus 2. And hit enter. And it gives you your next equation. And you have y equals, over on the very bottom here, negative 2x plus 7. Hit enter. Now watch this. If I click graph, right, it will show me the graph of what it should look like. But you can't really tell where the point is. So what I can do right here is I can look at my tables. I click second, that blue button in the top left corner. Maybe it's purple, I'm colorblind. And then click graph. See that button in the top right? It says table in blue. Click that. Now I can see my table. Okay, and if you look, I have my x values on the left and then the y1 And what you want to find is where these two values line up and are the same. So what it's saying is 3, 1 is my answer, because 3, 1 and then 3, 1 are the same. So if I graph it, right, if I go out there and get close to it, it looks like it's about 3, 1 where the points intersect. There's actually a more precise way I can do this as well, just to make sure, right? So this is a good way of going to the table. You can find it that way. Or another way that I can do it is by going to graph. Now that I have this, I can hit second calc, and then I want to see where they intersect, where these two lines intersect. So down to 5, click enter, and it says first curve is just asking me what's my first line I'm dealing with. The second line, what's the second line I'm dealing with, and it says guess. So I'm just guessing where I think my answer is going to be, and I click there, and it says the intersection's at 3, 1. So pretty cool. You could have either done it that way, or you can go to your second table and see that the answer is 3, 1. So you type your y equals in, you get your y1, your y2, you graph it, and then you can either check the table for the answer, or you can go in and calculate it by hitting second calc, intersect, which is 5, hit enter, and then guess. I'm guessing it's right there, and it gives me my answer, 3, 1. Pretty cool. All right, so now I'm gonna go ahead and do number 9. I just cleared them out. So I have 3x plus 1. Yeah, y is equal to 3x plus 1. Hit enter. And then I have 2x plus 3. All right, and if I graph it, right, it looks like it's up there somewhere. It looks about like 2, 6, 2, 7. Right, so if I go to my second table, sure enough, 2, 7. See how these numbers are the same? That's how I know it's the answer. Another way, like I said, I could do a good second calc, go down to intersect. I could say it's the first line, second line, and then guess where it intersects. Looks like it's about there somewhere. And the intersection is at 2, 7. Pretty cool. A lot easier than before. All right, so I'm going to clear them out. And then for number 10, you just know that y equals 5, right? That was the easy one that I did, right? Y equals 5. And if x equals -3, then I know that that's right there, -3, 5. That's an easy one. I don't even have to go through those steps. Okay. For the next one, like I said, I did for number 11. Number 11, it looked like it had the notebooks, and I had x plus, well, let me actually even pull it up. Let me see what I had here. I had my two equations. I had s equals, had negative x plus 6. I had to get y by itself, right? And then I had -5 over 4x plus 7, right? So those are my two. Notice I put my fraction inside those parentheses there. You can do that, okay? And I then want to be able to graph it. All right, looks very similar. And if I go to my table, right, look 4, 2. See how 4, 2 was my answer. And I had written 2, 4, and I'd written them backwards because in this case I wrote the equations the wrong way. Yep. So answer 4, 2 is where they intersect there. Okay. If I'm looking at this, 2, 4. Yeah, that's because when I wrote it, if I'm looking back at my original answer for number 11, I had mixed up my S and L instead of X and Y. Instead of being 2, 4, it should say 4, 2. And that's why I'm looking at my graphing calculator for the right answer. Okay, so going back to that problem right there, I had mixed up I got the right answer, but I just wrote it the wrong way. Instead of writing it 4, 2, I wrote it 2, 4. So that's why we use the graphing calculator. Okay, so 4, 2 would be the answer for that one. Then the last question, I'm going to go ahead and walk through it, and we'll do it together. The last question says, a shop has 1 pound bags of peanuts for $2 and 3 pound bags of peanuts for $5.50. If you buy 5 bags and spend $17, how many of each size bag did you buy? So I'm going to go ahead and work through this problem on a new layer here. And if I say, and maybe I'll just show you what I'm doing over here, right? If I have, before I use a graphing calculator, shop has 1 pound bag of peanuts for $2. So if I know that the 1 pound bag is going to be $2, and then the 3 pound bag is going to be for $5.50. If you buy 5 bags, so if I bought 5 and I spent $17, how many of each size bag did you buy? Okay, so we know that the 1 pound bag, I'll just go ahead and use that as, I'll use the 1 pound bag, I'll call that X, right? I'll call the 3 pound bag, I'll call it Y. And we know that if we buy a certain amount of, I'll move this over so you can see it. If I buy a certain amount of the 1 pound bag plus the 3 pound bag, right, I know I'm going to eventually get 5 bags. All right, and then saying that when I add them all up, right, it's going to be $2 times however many smaller bags I had, should be an X, right, plus 3 times, or sorry, it would be $5.50 times Y is going to give me 17. Okay, so I want to isolate Y in each one of these situations. So let's go ahead and do that. All right, so I'm going to start with the top one, right? So I'll bring that down there. I'll say Y is equal to Y is equal to negative X plus 5. And this one down here, I'll go ahead and move this up so you can see it. That's going to be 2X plus 5.50. Y is equal to 17. So what I'll do is, if I want to get Y by itself, I subtract 2X from each side. That gives me 5.50. Y is equal to negative 2X plus 17. And once I do that, I'm going to divide each side by 5.5. And that would give me Y is equal to, I'm going to put my calculator here. What is negative 2 divided by 5.5? And I get, if I put it as a fraction, looks like it's negative 4 over 11x. And then 17 divided by 5.5. If I put that as a fraction, so plus 34 over 11. Okay, so it's not pretty, but if I were to put both of those, if I put this one right here and this one right here into y equals, right? So check this out. I'm gonna go to my y equals, and the first one was, I'll just move this aside, I'll pull this out. Okay, it was negative x plus 5, and then I have negative 4 divided by 11 x plus, and then inside parentheses 34 divided by 11. Okay, and then I graph it. And let's just look at our graph and let's see what the table looks like. So if I go second and then table, it looks like 3, 2 is going to be my answer, right? So the answer is going to be 3, 2. And the way I can double check that, so if I go back to my work here, right? And if I say, all right, if I put a 3 in here for x and a 2 in for y, 3 plus 2 is still 5. I put a 3 in there, 3 times 2 is 6, and then 2 times 5.5 is 11, and 6 plus 11 equals 17, so that's right. So my answer in that case is going to be 3, 2. So my answer is 3, 2. And it would have been hard to graph this, right? And hard to graph trying to find the intersection point. So that's why I would use your calculator. And sometimes you're gonna have to go trial and error by hand if you don't have a graphing calculator, but I can't stress the importance enough of bringing a graphing calculator and using it. All right, and that is the end to homework number 9.